I wanted to try something different on my channel, so before I upload a video showing how to install a rear sway bar on your 6th generation Honda Civic, I wanted to go over some of the principles behind it. So I think this is one of the best modifications that you can do early on in a build in order to increase handling performance. I'll also show you how a sway bar works, covering at a very basic level, and then go over what some options are when it comes to shopping for a rear sway bar. So we'll take a look at the vehicle. Only the 1999 and 2000 model year Honda Civic SIs came with the rear sway bar. All the other models did not, but it's very easy to tell by looking at your car if it has a rear sway bar already installed on it. So if you were to look underneath the vehicle, what you should see are vacant holes. There should be one hole on each of your lower control arm assembly, and those holes are meant to accommodate the end links. And then you should see two holes on either side of your rear subframe, and that would accommodate the brackets that the sway bar assembly attaches to. So now let's look at some vehicle dynamics, specifically load transfer. So if a vehicle is going into a right-hand turn, as it makes that right-hand turn, there's going to be a load transfer, and the weight of the vehicle is going to shift to the outside tires and wheels. So in this instance, with the vehicle making a right-hand turn, load transfer is going to be to the left of that vehicle. An easy way to get a demonstration of this for yourself would be to put a tennis ball on the passenger side footwell of the car and then keep an eye on it as you're driving around. So for every action, there should be an opposite and equal reaction. So if you turn to the right, tennis ball should go to the left, and turn to the left, tennis ball should go to the right. If you accelerate, it should go back, and if you decelerate, tennis ball should go forward. If you've ever had a bad wheel hub bearing, you'll know that in order to tell exactly which side the bad wheel hub bearing is on, if you turn to the right and you get an increase in noise from the left-hand side of the vehicle, that means that your wheel hub bearings on the left-hand side are bad, because those are the ones that are under load. So now we understand the basics of load transfer. The next frame we'll go over vehicle dynamics and what you may be experiencing in your 6th generation as it comes from the factory, and that's understeer. So if the driver's making that same right-hand turn, we have the driver input looking to go right, and the vehicle is rolling about its axis. We have the load transfer to the left-hand side of the vehicle, so we have all that weight going to the left, which results in squat and dive on the left-hand side, and we have lift on the right-hand side of the vehicle. Now from the factory, your Honda Civic's equipped with a 22mm front sway bar. And again, it doesn't have that rear sway bar. So because it has a sway bar in the front, that means that the outside front tire is going to lose grip before the outside rear tire. And the result is understeer. So it's going to want to push rather than follow the exact driver input. And then understeer on this car from the factory is very noticeable. So it's not just when you push it, you'll experience understeer, but it's in driving everyday back roads that you should be able to feel the understeer and the excessive body roll. So in the next frame, we'll look at what we're trying to achieve by installing a rear sway bar, or an anti-sway bar, as they're also called, and which is a much better name for them. So by installing a rear sway bar, we're trying to get after neutral handling characteristics. So we have that same driver input going to the right, but rather than pushing to the left, we want the vehicle to actually follow that line. So with the rear sway bar installed, essentially that connects the left and right sides of your independent rear suspension. So what that means is we're still gonna have that load transfer to the left side. We're still gonna have all that weight coming down and the higher loading of the outside rear tire. And that higher loading is gonna result in a loss of grip before the front outside tire. So we're still gonna have that roll loading. With that, we're gonna see slight wheel lift on the right-hand side of the vehicle. And as that inner tire load is reduced, that results in less grip. So slight lift there on the inside rear tire, higher loading on the outside rear tire, and that's gonna shift the rear more in line with what the front of the vehicle is doing. So a rear sway bar on your car is going to result in increased roll resistance, more responsive steering, but it's also going to have an effect on ride quality. The easiest way to think about this, again, is you're connecting both sides of your independent rear suspension. So once you have the rear sway bar installed, when you're going over bumps, when you're going over road imperfections, you're going to feel it more. So an easy way to think about this, and it would be an extreme example, but if you think about what the handling characteristics are like of a solid rear axle vehicle, that would be just an easy way to frame what you could imagine with a very big rear sway bar versus a smaller rear sway bar. You're still gonna feel the effects on ride quality, but not as much as a big rear sway bar. And the Honda Civic Si from the factory was noted for having very neutral handling. And I'll post a link in the description below that shows a Motor Week review of the Si going through the slalom course. And that's the type of handling that I was trying to achieve. So in the next frame, briefly discuss oversteer and how that could relate to your Honda Civic. So if you were to install a very large rear sway bar on your vehicle, it's possible that you could develop oversteer. Again, if you think about it, you're losing some of the independence of the rear suspension. So we have that same driver input to the right. Oversteer is going to be pushing towards the inside, or actually sliding towards the inside of the turn. So again, we have that same load transfer. We have the weight shifting to the left of the vehicle. We have the front outside tires maintaining grip. But a large rear sway bar, if you can imagine, has a greater effect on lifting up that inside rear tire, and also a greater effect on loading up that outside rear tire. So what that does is that increased tire load actually breaks traction on the rear left-hand side of the vehicle, and the rear right-hand side of the vehicle, it's possible to actually get wheel lift. And if your tire has no contact with the ground, that means no grip, and that could result in a slide. And a good demonstration of that would be if you ever have seen a short wheelbase or even regular wheel-based front-wheel drive car with a large rear sway bar going around an autocross track, and you see that wheel lift on the inside rear tire. This would be immediately apparent. You'd start sliding out, and you'd hear a large tire screeching sound, very loud. And that would contrast where if you were right on the edge and you had achieved some very neutral handling, you would hear a soft squealing of your tires. So that would be more of a skrrr. And generally, a softly singing tire is a happy tire versus a loud screeching tire. Although one may be more fun depending on the conditions. But in day-to-day driving, I want to go over a condition known as lift-off oversteer, also known as snap oversteer. So we already talked about the load transfer of a vehicle being opposite to the driver inputs. And again, when you're accelerating, weight transfer is going to be to the rear of the vehicle. So that's important on a front wheel drive car where the weight distribution is roughly 60-40 front to rear. So if anything was to interrupt your acceleration, if you were to have to get on the brakes because somebody cut you off or because a deer ran out in front of you, or let's say you come into this corner too hot and you realize you have to lift all of a sudden or get on your brakes. If you have a large rear sway bar installed or a rear sway bar at all, it's good to be aware of this condition of snap oversteer, where the shift in momentum suddenly and the shift in weight from the rear to the front results in the rear of your vehicle swinging around on you. So in a right-hand turn, the vehicle would come out to the left-hand side, because again, that's where the weight's going to be, and you would ending up oversteering. And again, snap oversteer is going to be difficult to correct for, and if you're not aware of the oncoming symptoms of it, you may not be able to correct. So again, keep that in mind when it comes to selecting a rear sway bar for your vehicle. Now for any build that you do, you should first set your goals and let your goals drive your build. So for myself, I had to be very honest about the goals of this vehicle. So the first goal is to use it as a daily driver and a commuter car. That means I want to keep it comfortable and I want to keep gas mileage up, which means keeping it light. When I say keeping it light, I'm not just talking about the weight of a rear sway bar when it comes to different options. I'm talking about the other modifications that a large rear sway bar may drive, such as larger wheels and tires, maybe bigger brakes if the car is a more capable handling vehicle, and just looking at the car holistically. As I build this, I want to make sure that I keep it light. My second goal is to give it a sport injected feel. So I do want to reduce body roll, reduce understeer, and maintain the harmony of the build. What I don't want to do is build myself a race car. I don't want to eliminate body roll, and I don't want to induce oversteer. So if those are your goals, then just keep that in mind when it comes to how exactly you're going to modify the vehicle. Again, the harmony of the build comes down to making sure that the spring rate on your car matches the rear sway bar that you install. You don't want to install a hefty rear sway bar, but be riding around on stock springs on your suspension. And you also don't want to do that and then still be riding around on skinny all-season tires. I think right now the ones on my HX are 14 inches. The actual wheel is 14 by 5.5. So very skinny on all-season tires. It's not gonna be able to support as much as a performance tire on a larger wheel and tire setup. And then for myself, I wanted to keep the vehicle within a budget. I don't have infinite funds, and it is a 1999 with 200,000 miles. There's a lot of suspension components I need to replace. I am going to be putting money into the car, and I have to prioritize exactly how I spend that money. So looking at some rear sway bar options for your Honda Civic, before we go into what's out there, I want to touch on the fact that you should be aware the diameter or the size of a rear sway bar and the relationship it has to the stiffness of a rear sway bar. So if we were to look at a 13 millimeter rear sway bar, which is what came on the Honda Civic Si, compared to that of a 22 millimeter sway bar, even though the size difference isn't all that great, stiffness increases exponentially based on the size. So a 13 millimeter rear sway bar may produce 2.6 pounds per inch of stiffness, whereas a 22 millimeter rear sway bar may produce 13.3 pounds per inch. And that's a very big difference for a total of 9 millimeters difference in size. So be aware of that. A little bit of change in size makes a big difference as far as ride characteristics. So looking at the models from the factory, if you have an HX, EX, one of the other X's out there, from the factory, it came with a 22 millimeter front sway bar, didn't come with a rear sway bar, and I don't have the rates for that 22 millimeter front sway bar. The SI from the factory came with a 26 millimeter front and 13 millimeter rear. It's worth mentioning that the heavier a vehicle is, you have to use a larger sway bar in order to achieve the same effect. So even though that's a 26 millimeter front sway bar, you do have a larger B series engine up front. You have larger brakes, you have sunroof, so it is a heavier vehicle, so they went with a larger front sway bar there. 13 millimeter rear. That 13 millimeter in the rear stiffness rate is about 35 pounds per inch. Civic Type R, which wasn't sold in the United States, that had a 22 millimeter front and rear sway bar, and that rear sway bar rate is 292 pounds per inch. So a massive difference there. Also with a smaller sway bar in the front, there's going to be a lot more neutral handling to a Civic Type R, and I would say a tendency to oversteer as well. Looking at some of the Integra options out there. So Integra LS had that same 22 millimeter front sway bar out there installed on it. And then depending on the model and the year, it could be either a 13 or 14 millimeter rear sway bar. 14 millimeter sway bar being 1 millimeter larger than 13, but increases the rate to around 45 pounds per inch. And then the Integra Type R had a 24 millimeter up front, 22 millimeter rear for 292 pounds an inch, with the JDM Integra Type R having a 23 millimeter rear sway bar coming at 347 pounds per inch. So you'll see just 1 millimeter difference. Yet what a difference it makes there. You're looking at almost over 50 pounds per inch difference, whereas the 1 millimeter difference lower down the spectrum only had a 10 pounds per inch difference. So again, select what's out there based on what you hope to achieve. There are some aftermarket options out there, including ASR and Progress, with both have adjustable rear sway bars. I listed both of these companies because they're known to make a quality product and because they publish the statistics on the stiffness of their rear sway bar. If you're going to buy anything from the aftermarket, make sure that you do your homework and you buy a quality product. Don't buy something cheap off of eBay. And if you do buy a large rear sway bar, make sure that you buy a subframe brace to be installed with anything bigger than, I would say, around 16 millimeters. So I'll show you that real quick. So you want a rear subframe brace for a large rear sway bar because from the factory, the subframe itself is made out of fairly thin metal. And if you were to install a large rear sway bar on the vehicle and you send all of that twist, torsion, and motion through that rear sway bar, it could result in rear subframe tear out. So without a subframe brace, you could have a very bad situation on your hands when it comes to tearing out your rear subframe. One more thing I'll point out is, if you are to go to a junkyard and pick up a rear sway bar, off a 1999 or 2000 Honda Civic. You should be able to install the brackets on the vehicle and everything else, including the end links. Everything should work with your 6th generation Honda Civic. If you were to install, or if you were to get from a junkyard, an Integra rear sway bar, the brackets are different, as well as the end links and the lower control arms on your Honda Civic. So you would have to cobble something together. It would be a little bit more difficult to do, but not impossible. So there are a bunch of options out there, either picking something up used off the internet, off of a junkyard, or ordering from an aftermarket company. Personally, I would start small, but again, it depends on what your goals are. So I'll be installing a 13mm rear sway bar on my 1999 HX, which should give it a 22mm front sway bar with a 13mm rear. So in effect, that should give it more neutral handling than the Honda Civic SI, as the spread between front and rear is less than that of the SI. And also the HX has a lighter motor up front as well. So the weight distribution should be a little bit more even between front and rear.